Okay, so this is the example out here which is given out here. I mean, these are the kind of questions which actually can turn up in the real exam, right? And if you see what they're trying to say is that the stated rate was 4%, right? And the actual rate at a compounded level is about 4.08. So you have to figure out that what is the compounding level that is exactly happening. Now, there's no exact way of finding this because you can't really put it in the formula and find out directly. So it's just a hit and trial method, but mostly you can try it out with a 365 period, right? To just check. Because out here, I'm not giving you options, but generally there will be three options. The reason I'm not giving you options is so that you actually try to calculate this. But in the exam, my recommendation is just to try out with 365 first. If it does not work with 365, then just go quarterly and maybe monthly ones, right? So there are only three possible periods which are can exactly come. Now, please remember that the formula is finally future value is equal to PV into 1 plus R raised to N. This is the original equation. I told you always do not try to remember any specific formulas. This is future value is equal to present value into 1 plus R raised to N. And all that happens for having just trying to find this compounding for a specific rate is to just do a minus 1, right? Because all you're trying to do is remove the effect of present value, and that becomes your EAR formula, right? Now, what we're going to do is we're going to just try out with a specific rate of 4%, right? And let's say we just do 4% divided by 365, right? So the 365, let's say it's a daily compounding period, right? And raised to 365 minus 1. And you will get the answer as 4.08. So clean and simple, right? So if all you want to do is you just want to try out with 365 first on the basis of the options which are given, right? Generally start with a daily figure first and then try out the lesser frequency periods, right? So that's the whole idea of effective annual rate. Do not try to memorize it as always I'm saying, right? Now let's go into getting into time value of money with different frequencies of compounding, which I felt is more or less very simple. And you know trying to interpret future value, present value of different kinds of cash flow, because uh, until here we're just talking about one single investment, right? We're just talking about once we invest, which in other words we are also saying that it's a single cash flow, right? But now we can also try to look at two kinds of cash flow. One is that it keeps on happening, right? So more than one, is possible. And also the scenario of uneven cash flows. Okay, so how do we deal with it in terms of calculator as well as in terms of a manual calculation? Let's try to figure this out. Okay, now whenever we are talking about series of cash flows, there are some terminologies which the CFA curriculum has actually taken, right? Which is better understood in a timeline, okay, rather than just looking at these definitions. So if I just draw a timeline, okay, so if let's say this is 0, this is 1, this is 2, and I'm just gonna stick to some basic numbers out here, right? So if we are talking about annuity, so we are just saying that under normal circumstances, we are saying the cash flows are going to reoccur for some finite time. Okay. Uh, then you will see some parts of this which is ordinary annuity or annuity due. So the term to look out or the keyword is ordinary or due. Okay. And then there is perpetuity. So these are the only three kinds of cash flows which actually exist, right? So ordinary annuity, the first cash flow occurs, and this is general, right? Because when you start a business, also you will invest at this period, right? You will invest in this period, and then your business starts operating from here. So your operation starts from here, right? From one, and then it continues. So this is general case. Even in your, let's say, investments, even if you are doing continuous investment or regular investments of systematic investment plans, right? So this is how it will start, right? You might just add some lump sum out here, right? So initially you might just add some uh, lump sum out here, right? And then you might just start with your first sip 1, then 2, then 3. So this is ordinary annuity, right? However, sometimes as a concept, this is still discussed in the CFA syllabus, and it's actually true. It's good to discuss. Is that it might so happen in some products or some cases, you might have the first cash flow out here itself. So instead of the first cash flow happening at 1, it is now happening at 0, which is nothing but due. Okay. So that's the concept of due, that the first cash flow unnaturally happens at 0 instead of 1. Right. So that poses a problem for compounding, because imagine you started to invest. Let's say you put, you will have to actually create a table, try to understand this. Let's say we quickly create some calculations out here to understand this. Okay. So let's say this is 0. Okay. And you invested, let's say, 100 rupees. Right. So let's say I'm going to write it as initial investment, and then I'm going to write it as rate, and then I'm going to write it as end investment. So beginning of period, ending of period, right? So at 0, let's say I invested 100 rupees. Now, what this basically is telling us is that as soon as we invested, without even this entire 30 days or let's say 1 year happening, we immediately got, let's say if the rate is 2%, then we immediately got 2. Now, that's most likely not possible, right? Because the compounding period has actually not happened, right? As opposed to a normal case scenario, what will happen? So you will invest out here, right? And in the next period, so you've got exact 1 year or let's say 365 periods or 365 days or even 1 month for this to compound. And then your 2 actually comes out here. So this is the difference between, practically, difference between an annuity, ordinary annuity, and an annuity due, right? Now, what about perpetuity? Perpetuity just means perpetual. That means, the cash flow is infinite. All it means is infinite. Okay. Now, the reason why this is discussed in the CFA syllabus is for the perspective of valuation. When you're valuing a company, there is so much that you can actually forecast, because you can't really look for 100 years. I mean, you can't forecast a company's cash flows for 100 years, right? So there is an explicit period, right, that you forecast. You say that, okay, I'm going to forecast the company's cash flows for 3 years. Great. And future, nobody knows. So that's where perpetual concepts come. Perpetual growth, which keeps companies. So you want to value this. And that's the reason why it's actually discussed. Okay. In fact, the Gordon growth model also comes from the concept of perpetuity. Okay. So now this might seem like very complex, but let's come back to basics. Okay. It's not necessary that you really have to learn this formula. Okay. I personally, in practical world, would not use this formula, because all we need to do is just to find out what is the future value of an ordinary annuity. That means there is a reoccurrence of a cash flow at each period, right? So if I can see in terms of time value of money concepts, we have a couple of functions, right? We have rate, right, which is also called as I by Y. We've got N per or N, right? Then we've got PV, then we've got FV. But so far we have not discussed a concept of PMT, okay? So which is nothing but the payment function. So if you open up a calculator, you will see something called as payment, which is nothing but this cash flow repeating itself at every period. Okay. So you can try to learn this through this function also, but generally the benefit of doing this will not be very much, because in the exam you will have access to calculator, right? So if you want to read the explanation out here, you're free to do that, but my recommendation is just go with the calculator. It's much easier, right? So rate, if you see out here, the rate is simple. It's 5%. Great. So we're just going to write the rate. If you see, this is an ordinary annuity, so we don't really have to worry about. So we've got about 5 periods out here, right? We don't have a present value. See, at 0, we don't have. So PV is 0, right? So we will just write the PV as 0. That is what we are trying to find out, future value, right? So, and PMT, this is where we need to write this as 1000. Now, depending upon whether we are getting the money or we are paying the money, I'm going to assume that we are investing. So I'll just put PMT as 1000 and just press compute and press FE. and you will get the answer as simple as that. That's all that is happening. Now the technique, you can either skip this part, or you're free to even read through this. Okay, so simply put, what we're trying to do is remember the future value formula, in which we are saying PV into 1 plus R raised to n. Now forget about all these equations and just try to do this calculation yourself. Okay, so if again we say that PV is 1 and 1 plus 5%, right, raised to how many years do we have? We have got about 5 years. So if I try to solve for this 1 plus 5% raised to 5, all I get is 1.276282, right? Now, the way to solve this without a formula is to just find out the ratio of this. So that means we are saying 1 rupee or $1 became 1.276282 if we compounded it at 5%. That's all we're trying to say. How many times it is what we're trying to find out here, right? So again, just remove 1 so that we only are left with the return 0.26282, right? And just divide this by the original rate, which is nothing but 0.05, right? So if I divide this by 0.05, I will get how many times has the compounding happened. So you will find out, okay, that has happened about 5.52 times, right? And then you can just multiply this 5.52 times with 1000 and you should get the answer. So I felt that this is a little too complicated than necessary, because the calculation is as plain and simple as just using a calculator, right? So that's on it. That's annuity due. Now, if we are talking about uneven cash flow, see, the problem is this can only work with when you have a regular cash flow, but you can't work with uneven cash flows. What if the cash flow that we're investing at every period is different? See, so this can't work. So for this, you will have to use the cash flow function. Again, you can do this manually by finding out the future value of each of these cash flow and then adding it up. But there is a simple cash flow function in your calculators, which is, according to me, much useful. Okay, and just like there was an annuity factor that we found out, there is also a way of doing this exactly opposite, which is to find the present value. In that case, we were trying to find out the future value. Now, what if we want to find out the present value of ordinary annuity or ordinary cash flows, right? Which again are repeating with the same value. That means the values are same. This can only work when the values are same, right? So if you see this, you promise to pay about 1000 per year for 5 years, with first payment happening 1 year from now. The required rate of return is 12% per year. How much should you pay for this asset? Again, you can always do this in a calculator, because you have 1000, so PMT will be positive of 1000, right? You have a rate which is about 12% per year, and then you've got n as 5, right? So plain and simple, all you need to do is use the present value function and you should find the answer. However, if you do not want to use the calculator, again, let's go back to the original calculation, which if you remember, we have the future value is equal to present value into 1 plus R raised to n. Now, all I'm going to do is just rearrange, because we're going into the present value scenario. So rearrange and write future value divided by 1 plus R raised to n, right? Remember, just like the future value expression, we need to consider that remove the effect of 1, right? So if we try to remove the effect of 1 in this case, all we need to do is, instead of doing -1 out here, we can't do that because the expression is for present value. So it's going to be 1 minus this value, right? Again, doing the same thing, which is whatever my value comes out to be, which is 1 divided by 1 plus 12%, right, is compounded for 5 periods. So I will get 0.57, right? So all I'm saying is, okay, you know what, if I invest 1 rupee at 12% and compound it for 5 periods, 0.57 is what I'm going to get. But remember, I have to reduce 1 minus 0.57, so which gives me 0.43. Now again, I just want to find out how many times is this. So I'm just going to take 0.43, okay, and divide this by the original rate, which is 0.12, and I get a factor which is 3.60. 3.604,776, right? Now, what we're going to do with 3.604,776, you just multiply with this PV, which is 1000, and you will get the answer. So that's nothing but the present value, simple, right? It can be useful when you do not want to use calculator, but in the real world, calculator is what you actually use. So this is how you do it. As I said, I will be showing you how to use the cash flow function in a calculator. Very, very useful function. Okay. So this is where the function is there. Okay. So this is where the CF function is. The magic button is out here, right? So all you do is you press CF first. When you press CF first, it will give you CF0, which means the cash flow at 0. This means it's the cash flow at 0, which we don't have. So all you do is press this button out here, down arrow key. So it will take you to C01, which is the first cash flow. Now you put whatever your cash flow is, 1000, right? So you put 1000 and press enter. Make sure that you press enter. If you do not press enter, the value is not taken in the calculator. Okay. And when you press down arrow key, it will show you F01, which means it's asking you the frequency. This is nothing but the frequency. By default, it is 1. Okay. So you just press down arrow key again, and it will give you 6C02. And then the same thing will continue till wherever you want to take it, right? So you will continue till the 5th cash flow. And then after that, what you will do is you press I by Y. Okay. And you put whatever interest rate. So we have 5% interest. So you just put 5. And then press compute and press NPV. So that will give you the net present value. Okay. So very simple. But do, whenever you're using this cash flow functionality in the calculator, make sure you've done it, a couple of times, because sometimes it can just give you an error. You don't want to do that mistake in the exam. Okay, let's look at a question. So we have an investment which pays 300 annually for 5 years. Okay, so this is 300 annually for 5 years with the first payment occurring today. So this is due, annuity due. So the present value of the investment discounted 4%. So we want to find present value, that's for sure, right? And our PMT value is 300, right? And our discounted rate is about 4%. Okay. And future value is 0. So how are you going to solve this? So simple, use your calculator, but you will have to change the format from ending to beginning. Okay. So if you open up your calculator, you just need to go to your settings and change it to beginning, and then you can perform the same function and you'll get the answer. However, if you want to not use the calculator and you want to use the method that we just saw in our previous example, then again you'll have to do the same calculations as mine, which is to find out 1 divided by 1 plus 4%, right? Raised to, how many years are we talking about? We're talking about 5, right? So this will give you some value, 0.82, okay, 19. And if you remember, we need to find out 1 minus 0.8219, 1781. And then just we need to find out the ratio of this 0.1781 to 0.04. So that's the factor of 4.45. So that would mean 4.4525 into 1.04, which would give us 1389, right? So that's what the answer is also out here, right? Please do understand that the reason why we are multiplying it 1.04 is because in case of annuity due, we are getting 1 extra period for compounding. That's the reason why we are multiplying 1.04. Okay, present value of perpetuity is simple. You can actually do an exercise where you try to keep on, compounding 1000, forever, and then just try to find out the present value of each of these cash flows. You will realize that after some time, the present value keeps on decreasing and then converges to 0. Happens practically, right? So if you do it manually also and try to find out the answer, more or less this will match with, if you just take the cash flow, whatever you're going to get it forever, and just divide it by whatever the discount rate is, and you'll get a very good approximation. So that is what is present value perpetuity. This actually forms the, you can say, a foundation for Gordon growth model, in which in this case we are talking about a regular non-growth cash flow. There's no growth. Non-growth cash flow is approximated using this. But what if the cash flow actually grows? So in that case, what we do is you just multiply this cash flow into, and you grow it 1 plus g, whatever the rate is, and you you just reduce the discount rate with the growth factor. This becomes nothing but your calculation for terminal value in case of valuation. So I'm just giving an extra perspective so that you understand why we're discussing this in the first place. You will discover this when you'll actually read equity. So again, we're at LOSE, which talks about solving for different functions, which we have already covered in previously. But nevertheless, you can try out these examples. So let's start with the first example. So you have 1 million investments for 4 years, which becomes, so first and foremost, as I told you always, just to write down the values. So we have got PV as 1 million. We've got future value as 11.25508.81, and we know that the N is out here 4 years, and and PMT is 0, right? So all you need to do is compute I by Y, right? So it's straightforward, get the answer. Similarly, let's look at the second question. Again, put the values first. So PV is 1 million, right? Minus, make sure that present value is always negative. You don't want to do that mistake. Future value, same, right? Same as before. So 11.25, okay. And the rate is given as 3%. PMT is 0. And you need to compute N. There you go. So that's how you will find it out in the calculator. I would not recommend you to approach the log normal way, because you just waste a lot of time. The final one is that if you have a goal of reaching to 11.25508.81, so you've got future value. So you have future value in this case, which is 11.25508.81. You've got the N as 4. You've got the rate as 3. So you need to understand that the PV is 0. You are trying to compute PMT in this case. So if you see, a couple plans to pay the child's tuition for 4 years starting 18 years from now. So 4 years is what is the time period for paying the tuition, right? But that is going to start 18 years from now. And you have to be very careful with the numbers out here. Okay, so we are talking about 0. And then we are saying from 18 onwards, the payments will start. That means the investment period that we have is actually 17 periods, which is actually clearly given out here, right? 17 equal annual payments, right? Now, all you want to do is first put the data for both the sides and make sure that we have the data in place, okay? And sometimes people also do confuse that which part to solve first. Simple way to identify is that just go to 0 and see whether you have enough data or not, right? So if you go to 0 and see, present value is obviously 0 because we're not starting with anything, right? Future value, we don't know, right? Because we don't know what to save for, right? Rate we know, which is given as 6% as the investment returns that we can earn, right? And we also know the N, which is 70. However, we cannot solve for this because we don't know what we're saving for. So this part looks unsolvable. So we have to go to the second part and see whether we have some data for us to calculate, right? So if we see again from 18 onwards to about 22, right, we are going to obviously invest. So we have the N as 4, which is good. However, the investment or the cost of education is given as current at 7,000. So we need to, and that means that's the cost at 0. That's the cost of education today, right? So we need to find out what is going to be the cost on 18th, what is going to be the cost on 19th, what is going to be the cost on 20th and 21, right? Because 4 payments, right? So if you quickly calculate this, I already have the values. All you need to do is simply just multiply 7,000 into 1 plus whatever the inflation of the cost of education is, which is 5%. Okay, 5% raised to 18 first. Then the second would be 7,000 into 1 plus 5% raised to 19, right? Similarly, the same calculation into 1 plus 5% into 20, and same calculation 1 plus 5% into 21, right? So you will get values out here, which I'm gonna just quickly put in here. First value which comes up to be is 16,846. Then the second payment comes up to be 17,689, 18,573, 19,502. So we've got all the payments which the couples have to make for their education, right? Now what we're gonna do is we need to find out, since these are happening in different years, right? 1, 2, 3, and 4. So we need to get it back to 18. So what are we gonna do? We're gonna use the present value function, right? The present value is simple. You just need to take this value. So let's say the first education cost 16,846 divided by 1 plus whatever the present value is going to be, and that's going to be interest rate, not the cost of education. Okay, because your money is still there in the bank account, which is earning you 6%. So the discount rate has to be 6%, not 5%. Okay, so 6%, that would be your first payment. Plus you would do 17,689 divided by 1 plus 6% raised to 2 years. Then 18,573 divided by 1 plus 6% raised to 3. And lastly, the final cash flow, which is 19,502 divided by 1 plus 6% raised to 4. You might want to actually use the cash flow function. This can be done very easily in a CF function. So do try it out. Otherwise, you can obviously do it manually also, but it's gonna just take too much time, right? Answer. So finally, the answer which comes up by adding this, I'm just gonna quickly calculate. You can calculate by yourself. The thing that comes up out here is 62,677. Okay, so that's the amount of money that is required in the bank at year 18 to make sure that this actually happens. Now you come back to the first part of the question, which is now take the FE as 62,677 and now compute PMT. Now compute PMT. Now that should give you, calculated yourself, comes up to be 22,222 1.58. Okay, so plain and simple, but this would qualify as a little intense calculation question. But it's easy if you are able to create a timeline, right? So that brings us to the first end of the first reading on time value of money. I've spent more time out here because this tends to create a more base for you when you'll actually look at some complex calculations in further slides, and specifically when you get into other study sessions into equity or derivatives. So these concepts have to be very clear and have to be understood not from a formula perspective, but has to be understood from a fundamental perspective. So if you understand from fundamental perspective, it's easy. If you try to memorize the equations, I don't think so that would be a very comfortable journey, right? So I'll see you in the next lecture. Bye bye.